This lecture on the laws of sines and cosines is presented on behalf of the Independent Learning Center of SKU. My name is Gerald Wanjala. To begin with, let's consider the triangle given below. This triangle, or any other triangle for that matter, has 6 parts. The triangle has 3 angles, A, B, C, and 3 sides, small a, small b, and small c. To solve this triangle means to determine all its parts from the information known about the triangle. A triangle can be solved if 3 of its parts are known, as long as at least one of these parts is a side. Let's consider the triangle ABC, which is given here below. The law of sines says the following. In a triangle ABC, we have that the sine of angle A divided by A is equal to the sine of angle B divided by B, and that is equal to the sine of angle C divided by C. Now, in solving triangles, one may encounter the following cases. Case 1, you may be given a triangle where a side is given and 2 angles. You may be given a triangle ABC where 2 angles are given and 1 side is given, and you are required to solve that triangle. Now, here is the example where we are given 1 side and 2 angles. So we have, in this case 1, we have the angle here which is given, the side here which is given, and the angle here which is given. The side lies between the 2 angles. So that case is referred to as angle, side, angle, ASA. But you can also be given, for example, this side here, this angle here, and that angle here. In that case, you are given the side and an angle and an angle. So we refer to that as SAA. The second case, you may be given a side and an angle. For example, you have this side, and that angle. So in case 1, you're given 2 angles and 1 side. Case 2, you are given 2 sides and 1 angle. Case 3, you are given 2 sides and 1 angle, but the angle is in between the sides. So for example, you have this side, this angle, and this side. So that case is given as SAS. And the last case, which is case 4, you are given 3 sides. So that's given as SSS. Cases 1 and 2 can be solved by applying the law of sines, and cases 3 and 4 can be solved by applying what we call the law of cosines, which we will see later, in combination with the law of sines, or you can apply the law of cosines alone. Case 1, where we are given 2 angles on one side, always has a unique solution. You will always get 1 solution for this case. Whereas case 2, where you are given 2 sides and an angle, you will either get 1 solution, or 2 solutions, or no solution at all. So let's look at the various cases. Let's look at the case where 2 angles are given, and we have this a side which lies between the 2 angles. So you have angle, side, angle, ASA. So the example says, use the law of sines, solve the triangle ABC, where angle A is 40 degrees, angle B is 80 degrees, and length C is 35. So since we know that AB is a triangle, and we know that angle A plus angle B plus angle C should give us 180, therefore angle C should be 180 minus the sum of angles A and B. So that gives us that angle C is 180 minus 40 plus 80, and that will give us 60 degrees. So angle C is 60 degrees. From the law of sines, we know that sine A over A is sine C over C, and that sine B over B is equal to sine C over C, and therefore it follows that A can be written as A is equal to C sine A over sine C, and that is equal to 35 sine 40 degrees divided by sine 60 degrees, which will give you approximately 26. So A is approximately 26. And also from the law of sines, we see that B can be given as B is equal to C sine B over sine C, which is equal to 35 sine 80 divided by sine 60, and that will give you approximately 40. So we have solved the triangle ABC. So the angle A is 40, the angle B is 80 degrees, and length C is 35. We have angle C is 60 degrees, length A is 26, and length B is 40. Case 2, we look at where two sides and an angle are given. So this is the case side, side, and angle, SSA. Let's begin with the one solution case. So the example 2 says, solve the triangle ABC, where angle A is 60 degrees, length A is 10 root 3, and length B is 10 root 2. So first we find angle B. From the law of sines, we know that sine A over A is equal to sine B over B. So sine B can be written as sine B is equal to B sine A divided by A, and that is equal to 10 root 2 sine 60 divided by 10 root 3, and that gives you root 2 over root 3 times sine 60, which gives you root 2 over root 3 times root 3 over root 2, because the sine of 60 degrees is root 3 over 2, and eventually that gives you 1 over root 2. So we see that B is an angle whose sine is 1 over root 2. Now there are two angles which are less than 180 and which have their sine as 1 over root 2. These two angles are 45 degrees and 135 degrees. Now, since angle A is given as 60 degrees, we see that angle B must be 45. Angle B cannot be 135. Why? Because 135 plus 60 is already more than 180. But since A, B, and C are angles of a triangle, then A plus B plus C should add up to 180 degrees. So we see that angle B cannot be 135. So that leaves us with only one option, that angle B is equal to 45 degrees. And therefore, we see that angle C, which is equal to 180 degrees minus 60 degrees plus 45 degrees, will give us 75 degrees. So the equality sine B over B is equal to sine C over C implies that C can be written as B sine C over sine B, and that's approximately 19.3. So we have solved the triangle. We have that angle A is 60 degrees, angle B is 45 degrees, angle C is 75 degrees, length A is 10 root 3, length B is 10 root 2, and then length C is approximately 19.3. Example 2, we still look at SSA, where the sides, side, and angle are given. But this case, we look at the two-solution case, a case where you have two solutions. Example 3 says, solve the triangle ABC, where angle A is 30 degrees, length A is 8, and length B is 8 root 3. So first we find angle B. As before, we know that sine B can be written as sine B is equal to B sine A over A, and that is equal to 8 root 3 sine 30 degrees divided by 8. That can be written as root 3 sine 30 degrees, and this is root 3 times 1 over 2, because the sine of 30 degrees is 1 over 2, and that will give you root 3 over 2. Since angle B must be less than 180 degrees, and sine B is root 3 over 2, it follows that either B is equal to 60 degrees or B is equal to 120 degrees. These are the two angles which are less than 180 and which have a sine of root 3 over 2. Now, since angle A, which is given in 30 degrees, we see that both angle B equal to 60 degrees and angle B equal to 120 degrees are possible solutions. So let's call one of the angles B1, the other one B2. So let's set B1 to be equal to 60 degrees and then B2 to be equal to 120 degrees. Then in this case, we have that angle C1, which corresponds to A and B1, will be given by 180 minus 30 degrees plus 60 degrees, which will be 90 degrees. And angle C2, which corresponds to A and B2, will be given by 180 degrees minus 30 degrees plus 120 degrees, and that will give you 30 degrees. Hence, C1, which is given by B sine C1 divided by sine B, will be equal to 16, and C2, which is B sine C2 divided by sine B, will be equal to 8. So the two solutions are: 1, angle A equals 30 degrees, angle B equals 60 degrees, and angle C equal to 90 degrees. Length A equal to 8, length B equal to 8 root 3, and length C equal to 16. The other solution is angle A equal to 30 degrees, angle B equal to 120 degrees, angle C equal to 30 degrees, and length A is equal to 8, length B is equal to 8 root 3, and length C is equal to 8. So in this case, we have two solutions. The other case is the no solution case, when you are given two sides and one angle SSA, the case where you have no solution. So this is considered under example 4. The example says, solve the triangle ABC where angle A is 45 degrees, length A is 10, and length B is 20 root 2. As before, let's try to find angle B. We have that the sine B is equal to B sine A divided by A, which will be 20 root 2 sine 45 divided by 10, and that will give you 2 root 2 times 1 over root 2, because the sine of 45 is 1 over root 2, and you see that this whole expression is equal to 2. Since the sine of an angle is never bigger than 1, we conclude that there is no triangle which satisfies the given conditions. In this case, we have no solution. Next, let's look at the law of cosines. The case when you are given two sides and one angle, or all three sides, can be solved using the law of cosines. So let's consider this triangle given down over here. The law of cosines says, in any triangle ABC, see the figure above here, we have 1, that A square is equal to B square plus C square minus 2BC times the cosine of A. 2, B square is equal to A square plus C square minus 2AC times the cosine of B. And lastly, C square is equal to A square plus B square minus 2AB times the cosine of C. So how do we apply the law of cosines? Let's look at the case where you are given two sides and one angle, SAS. So this is considered in example 5. The example says, solve the triangle ABC, where angle A is 120 degrees, length B is 10, and length C is 18. First, we find A using the law of cosines. We know the law of cosines tells me that A square is equal to B square plus C square minus 2BC equals A. That gives me 10 square plus 18 square minus 2 times 10 times 18 times the cosine of 120, and that will give you 604. And therefore, A is the square root of 604, and that will be approximately 24.6. Now, from the law of cosines again, we can see that cosine B can be written as cosine B is A square plus C square minus B square over 2AC. And that will be 604 plus 324 minus 100 divided by 2 times 24.6 times 18, and that will give you approximately 0.935. Now this tells me that the cosine of B is approximately 0.395, and therefore B is an angle whose cosine is 0.935. And if you use a calculator, then you see that B is approximately 20.8 degrees. Now, since I have angle A, I have angle B, and I know A plus B plus C is equal to 180, I can get C as 180 minus the sum of A and B, and that will give me approximately 39.2. But I can also apply the law of cosines as indicated here. I can say cos C is equal to A square plus B square minus C square over 2AB, and that will give me the cosine of C to be approximately 0.772. So C is an angle whose cosine is approximately 0.772, and therefore C is approximately 39.2 degrees. The last example is example 6, where we are given 3 sides and no angle at all. So that is referred to as the case SSS. The example says solve the triangle ABC, where length A is equal to 20, length B is equal to 25, and length C is equal to 22. So from the law of cosines, we see that cos A is equal to B square plus C square minus A square of 2 divided by 2BC. And that is the same as 625 plus 484 minus 400 divided by 2 times 25 times 22, and that gives you approximately 0.645. So A is an angle whose cosine is approximately 0.645, and that means that A is approximately 49.7 degrees. Similarly, we can use the law of cosines to see that cosine B is approximately equal to 0.294 as indicated over here, and that B is an angle which is approximately 72.9 degrees. Now, since we know that A plus B plus C is equal to 180, we can get angle C as C is equal to 180 minus A plus B, and that will be approximately 57.4 degrees. But you can also get angle C using the law of cosines as indicated here. We have that cosine C is equal to A square plus B square minus C square divided by 2AB, and that will give you approximately 0.541. And so that tells you that C is an angle whose cosine is approximately 0.541, and so C is the angle which is approximately equal to 57.4 degrees.